In this video, I'm going to demonstrate how to configure a Unidrive M700 to operate a permanent magnet motor for a servo application. I'll be using MConnect software to set up the drive in RFC-S mode, which stands for Rotor Flux Control for Synchronous Motors. After that, I'll be configuring the servo motor options, and then I'm going to show you how to perform an auto tune to optimize motor performance. So if you're ready, let's get started. I've opened up MConnect software and I've already started a new project. I'm not connected to the drive right now, so I've simply added the Unidrive M700. And the other thing you should note is that I have configured the slot 4 Ethernet port on the drive for this IP address, so that when it comes time to download this project into the drive, I won't have to stop what I'm doing and reconfigure it. So those are the only two things that I've done in advance. What I'd like to show you first of all is we're going to set the mode of operation for the drive to Rotor Flux Control RFC-S for synchronous motors. Synchronous motors are synonymous with servo motors. So to do that, I'm going to come over to Set Mode and Region, and this lists the 4 options that are available for the operating modes on a Unidrive M700. By default, it's open loop mode, but I'd like to change it to this RFC-S. So to do that, I'll just click, and it gives me a nice little write-up here that explains a little bit about this operating mode. And as you can see, it's synchronous permanent magnet motors. The next thing that's very important is to choose the region. The region determines a set of default parameters that will ultimately be placed in this parameters folder. So I'm here in the US, so I'm going to choose 60 Hertz, but if you are in areas where 50 Hertz is prevalent, then choose 50 Hertz from that list. So I'll click Apply, and now it's configured my project for rotor flux control for synchronous motors, 60 Hertz defaults. The first thing I'm going to do after setting the operating mode is to configure the motor itself. Now the motor settings are in the parameters over here. If I expand this, the motor settings are contained in menu 5 and menu 3. Now if you didn't know our menu structure, we've made it easy for you to configure your motor by using the setup view here, and then just choose motor setup like so. So I'll click that, and what you see here is the Unidrive M700 supports 2 motor maps, Motor Map 1 and Motor Map 2. We're going to use Motor Map 1, and what I need to do here is I need to populate these fields with the information from my motor name tag. Now if I knew what that was, I could simply type them in here, but what I'd like to show you is our motor database that gets installed alongside MConnect. So I'll click Choose a Motor here. And what that's going to do is that's going to open up our motor database. Now I've customized my motor database a little bit to include a couple of extra, or a few extra columns here. If you right click on any one of those columns, here's where you can choose what information out of the database is displayed. So as you can see, I have added the motor KT, the motor KE, and the thermal time constant right down here. So the model number of the motor that I'm using today is a 067 EDA 300. So to resort the database and bring our motor a little closer to the top, I'm going to click Model. And then I'm simply going to scroll down until I see 067 EDA 300. There it is. So I'll choose that motor, and then I'll click OK, and that will populate this Motor Map 1 for me. The most important thing is, because I am not connected to the drive now, I'm offline, I need to save these settings to my project. So to do that, click this button right here. Now the software has transferred the motor map information into the appropriate drive parameters in menu 5. So now that we've got the motor settings in there. The next step is going to be to configure the motor feedback. And once again, the motor feedback is in menu 3, but if you didn't know that, you can simply choose Setup, Motor Feedback Setup, right there. So the Unidrive M700 has a high-density 15-pin encoder feedback port that is split into two different ports, port 1 and port 2. Port 1 is primarily designed, as you see here, for the primary motor position feedback, and that's what we're going to be choosing today. So the encoder type that I'm using on this motor is an NDAT encoder. So I'll simply come down here and choose that. And here are some of the options that I can elect to change if I would like. And if I scroll down, there's more down here at the bottom of the screen. But these will work for me for default. So I'm going to click Save to Project. Now at this point, I'm ready to transfer this project down to the drive. MConnect software has, as part of the Setup Tools folder, an Autotune wizard. The Autotune wizard is an automated tool that walks a user through the steps necessary to perform an autotune. The drive uses the autotune process to optimize the performance of a motor by measuring its electrical characteristics, such as stator resistance and inductance. There are two options, stationary and rotating. If you're operating a motor with encoder feedback in RFC-S mode, like we are in this video, then a rotating autotune is imperative. The reason for that is that the drive needs to know the relationship between the rotor flux field in the motor and the encoder. This is called the position feedback phase angle. Without measuring this, the drive won't be able to properly commutate the motor. Also, it's important to note that you must have the ability to open and close the drive's safe torque off terminal when using this feature. Lastly, it's also important to note that the motor be disconnected from any load during the autotune process. So let's see how this works on the project that we've started. I've already downloaded our project into the drive, and I have MConnect here. I'm going to go online with the drive in order to do the autotune. So I'll click there, and that will connect me to the drive. Before we actually do the autotune, it's important to note what the drive reference mode is. And to find that, I'm going to open the parameters folder here, and I'm going to double-click on menu 0. Specifically, I'm going to have a look at the drive reference selector, which is in menu 0, parameter 5. Right now the drive is set up in analog control mode, and in this mode the drive Autotune wizard will automatically provide the run signal necessary to do the autotune. However, you should note that if the drive is set up in keypad mode, for example, like that, then you must press the green button on the keypad in order to initiate the start signal that's required by the autotune. So for this demonstration, we'll just leave it in A1, A2 mode. And now I'll begin the autotune. The autotune is located here in the Setup Tools folder. So I'll drop the Setup Tools down, and I'll come down and choose Autotune. Here's the first page of the Autotune wizard, and as you can see, there's some instructions about safety highlighted in red. And then as I move down the screen here, what type of autotune test should be used? There are two choices, stationary and rotating. Since my motor has an encoder on it, I'm going to choose rotating. You're also able to choose which direction the motor will rotate during tuning and where the motor measured parameters are stored. This is motor map 1, so it's going to be stored in menu 5. Everything looks good there. I'll click Next. The drive status here says the auto-tuning can continue, so I simply need to click Next. And then it says to start the auto-tune, please enable the drive by activating the safe torque off input. So I will do that. I will close the safe torque off switch. And now the auto-tune is in progress, and you can see and maybe even hear the auto-tune as it's running. The elapsed time will be shown here. And it does take, I think it'll take about 35 seconds for this to complete. You should also pay attention to the fact that the motor is rotating. So again, it's critical that the motor not be connected to the load during this process. So it's continuing to make its measurements here. There, it just finished. So it says to complete the auto-tune, please remove the drive enable safe torque off. So I'll do that. And then I'll click next. Now what it shows here, it shows that it has successfully completed the auto-tune. But look here, here is what was changed during the auto-tune. Here are the measurements that the drive took. There's the position feedback phase angle that we just discussed. And it also sets up the gain terms for the current loop. So you see we have a couple of gain terms for the current loop here. Measure the stator resistance here and the inductance. So at this point we have successfully completed the auto-tune, and the last step here is going to be to save those parameters in the drive. Don't forget to do this. So once the drive parameters are saved, we have now successfully completed an auto-tune. Thank you for watching this video. I hope you found it informative, and if you have any questions, I can be reached at the email shown here. Please refer to the training section of our website for more information about our training courses and to see our current training schedule.